Problem number 19 in 8.1 relates to example 5 in the textbook, and what it has to do with is this. It says, if a woman is currently working, the probability is 0.8 that her daughter will also work. So 80% of women who work, their daughters will work, and if the woman is working, there's a 20% chance that her daughter will not work. If the mother is not working, there's a 30% chance that daughter will be working, and if the mother is not working, 70% of those daughters will also not work. Now in problem number 19, we are told that currently, so I'm going to write that as P naught, this is our initial state at time 0, currently 47% of French women are working, so therefore these have to add up to 1, 53 are not working. And we are asked to find the percentage of daughters who are working, women who are working in the next 2 generations. So we have some formulas for this. We can write this. The next generation would be P1, right? Our initial generation is P sub 0, so the next generation is going to be P1, and P1 by our formula is T times P naught. In 2 generations, that's going to be P2, and that will be T squared times P naught. So let's make this computation here. So I'm going to bring this down, and T, well, T is right here, right? So let's write that. That's going to be down the columns, 0.8, 0.2, 0.3, 0.7. And we're going to multiply this by P naught. Now, P naught, that's right here. That's the current state, and the current state is 0.47.53. And we're going to multiply these 2 matrices. Now when I multiplied these, I got 0.535, 0.535, and 0.465. And this is the percentage of daughters who are working and the percentage of daughters who are not working. So we know how we got this product, right? We multiply over and down, multiply and add, over and down. But that is going to be a little cumbersome, especially when we're trying to get powers like this one to raise transition matrices to powers. So let's take a look in the next video at a software package called Wolfram Alpha that will allow us to make these multiplications pretty easily. But for now, let's just finish this problem here. So what we're going to have is P2 is going to be T squared. So we're going to take our transition matrix 0.8, 0.2, 0.3, 0.7. We're going to square this, and then we're going to multiply it by the current state, 0.47, 0.53. Now I used the Wolfram Alpha package to get this matrix. I got 0.5675, 5675, and 0.4325, 0.4325, but this would be working and not working. So let's see what we've just said here. And if the current state is this, 47% of women are working and 53% are not, what about the next generation, their daughters? Well, their daughters, here's what we'll have. 53.5% will be working, 46.5% will not be working. That's assuming that this remains the same. And of these current mothers here, their granddaughters will have these percentages. 56.75% will be working and 43.25% will not be working. Problem number 20 says to use the same transition matrix as we did for American women, now for Belgian women, and currently we're given that 44% of Belgian women work, 6% don't. And we're asked to do the same thing that we did back in number 19. So we want to find P1. Now P1 we know to be T times P naught. So we're going to have T, 0.8 down the columns, 0.2, 0.3, 0.7 times P naught. And P naught, in this case, is what we're given, is 0.44, 0.56. And when I computed that, I got 0.52 and 0.48 working, and not working. So let's just summarize what we're saying. So currently, if 44% of women are working, and their daughters, the next generation, 52% will be working. And for granddaughters, we're going to have P2, that's equal to T squared P naught. So this is going to be 0.8, 0.2, 0.3, 0.7, square that, and then multiply it by the current state, 0.44, 0.56, and that comes out to 0.56.44, working and not working. And I think it's a good idea now to go to the next video to take a look at our package here, Wolfram Alpha, to see how we're going to use it to make these multiplications.